Hello everyone, welcome to Modern Physics online class. Today, we will have another discussion focusing on the wave nature of particle, specifically the electron. But before that, let us start our day with a simple guessing game entitled Crack a Code. Did you understand the instruction, class? If yes, so let's start. I hope that you get all of the 6 words. The wavelength, particle or particles, momentum, electron, Planck's constant, and the velocity. Because all of that words are related and will be used in today's discussion of the de Broglie equation. But before that, let me present to you our learning objectives. And as we go through the discussion, you might encounter these terminologies that may seem unfamiliar to you, like this, the momentum and the wavelength. Now, for our next activity, we'll be going to conduct a group analysis and sharing of a learning materials which I entitled How de Broglie Derived His Wavelength Formula. Now that you already know how the equation has been derived, let us use this in computing this problem.
An electron of mass 9.11 times 10 raised to negative 20 kilogram moves at nearly the speed of light. Using a velocity of 3 times 10 raised to 8 meter per second, calculate the wavelength of the electron.
But first, let's write what are the given on the problem. So the mass is 9.11 times 10 raised to negative 20 kilograms. The velocity is 3 times 10 raised to 8 meter per second. And the Planck's constant is 6.62607 times 10 raised to negative 34 joules per second. And we are going to find the wavelength. So here, H divided by M, V. So substitute the Planck's constant, the mass, and the velocity. So when we multiply the mass which is 9.11 times 10 raised to negative 20 kilograms, and 3 times 10 raised to 8 meter per second, we will get 2.73 times 10 raised to negative 11 kilogram meter per second. So, divide the Planck's constant and the 2.73 times 10 raised to negative 11, and we will get 2.43 times 10 raised to negative 23 meters. So that is the wavelength of that electron. Now try to solve this problem. So this is the answer to the problem. I hope you get the same answer, which is 1.77 times 10 raised to negative 36 meters. If you get the same answer, it means that you already understand the de Broglie wavelength, especially on how to solve the problem using this formula or equation. Another thing that you must remember is that the momentum, or P, or the mass in motion that we define in the terminologies, is equal to the product of mass and velocity. So, we can say that P is equals to m times v. So, it also means that we can write the equation, or the de Broglie wavelength equation, like this. Now, let us talk about the real-life situation where this equation is commonly used. So, we are going to have another activity entitled Think, Share, Then Decide. The de Broglie concept is mostly used in construction of electron microscope, which is used in measurement of objects of very small size. But not just in electron, it can also be in proton and in neutron, and other micro-sized particles and macro-sized moving objects like cars, balls, and etc. So for the last part of this lesson, please answer the following. And for your assignment, please answer this one. That's it. We are done in our lessons of the Broglie equation. I hope you learned. Thank you.